All right, calculus. So you got a beanie on. Number one, my hair was driving me nuts. Number two, I'm trying to wear a different hat at all times. So I'm running out of hats. So I got to figure out some different hats. So you never know. Uh, Here we go. Let's see here. Limits. Limits as x approaches infinity. So we already talked about the trigonometric functions and how they approach zero and the properties that they exhibit. Well, infinity does the same thing. It displays kind of what people call the principle of dominance. And so we're going to kind of talk about that. In this piece right here, this limit as x approaches infinity of 1 over x equals 0. It's kind of like a really important theorem for you guys to kind of look at. So what we need to do is kind of tackle some different types of problems here and kind of look at them. So let's just kind of talk about this idea here first, so we can kind of see what happens with infinity. So we end up, first thing we do is plug it in, right? That's our first rule. So we get the limit as x approaches infinity of 1 over infinity. And everybody's like, well, big deal. So the idea is that remember that infinity is this concept that it's such a large number that you can never get there. So as this thing gets larger and 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 larger, this fraction, because this is a number, gets smaller and smaller and smaller. And so the idea of limits is, what is it approaching? Well, it's got to be approaching 0, because this keeps getting bigger. That means that keeps getting smaller. So sooner or later, when we find infinity, there's going to be nothing there. That's why they haven't found it yet. All right. So this concept of the idea that infinity is so large plays a big role in what we have to deal with. So there's multiple ways to look at this, but infinity is such a huge conceptual problem that you got it's because you can't see infinity. Infinity's tough to work with, and so we've just got to tackle some different types of problems. So on the top of your guys' worksheet, it has some different things about if it's less than b. There's some different ideas. We're just going to tackle some examples today to go with it. So let's just look at this. Limit as x approaches infinity of x plus, oops, I think I messed up already. I did. 5x plus sine of x over x. So there's some ideas that we have to deal with here. So let's look at this piece. This piece right here. Did I write that down correctly? Oh yeah, I did. So here we go. So if we look at this, I can rewrite this as this piece. And fraction-wise, I'm showing you these because we got to learn that since there's a common denominator, we can split these fractions. So we can split the numerator. This is a key skill I want you guys to remember. Make sure you know you can split those bad boys. All right, so if we're looking at this, and just kind of stop, don't fall into the trap. This is not just a random 1 right here. It can't be, because it's not approaching 0, it's approaching infinity. Totally different type of problem. So let's just kind of look at this piece as we separate it out. So we're going to go ahead and say, oh, the limit as x approaches infinity of 5x over x. We just kind of do a little bit of work there. Those cancel, right? So I'm left with 5. But let's look at it this way. What if I put in the idea of, if infinity is x and I put infinity here and infinity here, what's going to cancel out? My infinities. So what's left? My 5. So I'll do that here in a second. So I'm going to put my x's back, okay? So my x's come back, and I'm just going to say, well, this is going to be 5. I already know that. It's going to be 5. This one becomes a little bit of an issue here because we're adding the limit as x, I forgot my x, as x approaches infinity of the sine of x over x. So here's my question. This guy right here, this person right there, what if I put infinity? You're like, that was not on our trig reference sheet. That's never been on our trig reference sheet. That's not anywhere on the unit circle. It's not. But remember, this represents theta. So what's the biggest thing that this thing can equal? Doesn't matter. What's the biggest thing? Well, it can equal 1. That's the biggest thing it really can equal. Well, what can this equal? This can equal infinity. Well, if this is 1 and this is infinity, what is it going to equal? It's going to equal 0. So our idea is that this is going to equal 0. So my answer is 5. So the limit equals 5. Okay? So that's one way to tackle them. So we've got, and again, guys, remember the concept. This is the concept we're pushing. This guy here. And the principle of dominance is that. This one is dominant over that one. So we're going to see which way it goes. It's going to approach infinity. It's going to do some different things. So let's look at a little different one here. Some of them are pretty straightforward. Let me look at another one here. They're not playing nice today. Here we go. Let's look at something like this here. The limit as x approaches infinity of something like 3x to the 4th minus 2x cubed plus 3x squared minus 5x plus 6, and we have 3x to the 4th. Okay, so we've got this piece right here. So there's this idea like, holy smokes, if I plug infinity to all this, I can't do the math on that one. So let's just kind of mess around with it a little bit. What did I tell you guys you can do? Remember, it's the same denominator, so we can split this thing out. So we're going to say the limit as x approaches infinity, we're going to split it out. X squared over, 3x to the 4th minus 2x cubed over 3x to the 4th plus 3x squared, this is the long way by the way, x to the 4th, minus 5x over 3x to the 4th plus 6 over 3x to the 4th. So let's just kind of look at this real quick and say, okay, so I've redone it. So I took this and I split it out. Remember, I said it's a skill that you can have. And I looked at it and I say, okay, if I plug infinity into this, I'm going to have 1. It's the same exact thing. So I'm going to get 1. If I plug infinity to these two, this infinity grows faster than this one because this degree is smaller. So this is infinity times infinity times infinity, but this is infinity times infinity times infinity. So if it grows at an infinite faster rate, this is going to get bigger much faster than that, so it becomes 0. This one here, same thing. This gets way bigger faster than this one, so this is going to be 0. This one, same thing, way faster. X to the 1st over x to the 4th, 0. 0. So all that work gives us an answer of 1 equals 1. So this is how you show it using the principle of dominance or law of dominance, right? So, because this infinity is going to dominate over that one, it's becoming 0. So if we get to that piece, and you look at it, you go, wait a sec. What if I just took the denominator and the largest exponent on top, and I looked at it, those cancel out. 3 divided by 3 is 1. There's a lot shorter ways to look at things that will get you through a little bit faster, but splitting them out will get you the answer if you're stuck and you're not sure what you need to do. Let's do another one here. Let me throw a different one at you. So, let's do the limit as x approaches negative infinity, negative, of 5x to the 7th plus 3x squared plus 4x minus 2. I'm making this one up. Over 2x to the 4th. So here we go. Let's write it out. I want you guys to guess and see what you guys come up with. Okay? So if we're looking at this, I'm going to split it out. I can split it out 5x to the 7th over 2x to the 4th. And then I've got plus 3x squared over 2x to the 4th plus 4x over 2x to the 4th minus 2 over 2x to the 4th. I'm looking at this. I'm plugging in a negative infinity. Let's tackle these back here first. This is way smaller than that, 0. This is going to be the numerator is going to be way smaller than the denominator, 0. Way smaller than the denominator, 0. Gotta love infinity. All right, so we're stuck with this guy. Let's just do a little math, a little algebra. What do I get? I get 5 halves x to the 3rd. Right? Maybe, don't know. So what happens with this? These things grow so quickly exponentially. What we're going to end up doing is we're going to be growing towards negative infinity. So this thing is going to, limit is going to be negative infinity. It's going to get so big, so fast, faster than that one, it's going to become negative infinity. All right? So if I drew this one back here, 5 halves, x to the 3rd, plug that in, I get negative infinity times negative infinity times negative infinity, which is going to be negative infinity. So kind of pulling this stuff all together, as you guys look at it, if I just look at the largest exponent up here and the largest exponent, or that in the denominator there, I end up figuring out what I can plug in based on the principle of dominance. I can come up with my infinity pretty quickly. So let's tie it all together at the very end right here. So, if we're doing limits to infinity, there's a couple of styles. There's 5x squared over 3x squared. When these are the same, you take your coefficients out front. That's going to be your value. Okay? And then let's look at this one. So when these are the same, don't forget when these are the same. When we have 7x to the 6th over 5x to the 7th, the larger exponents on the bottom, this is going to grow much more rapidly than the numerator, so that's going to be 0. So when the exponents are in this kind of formation, your limit's going to approach 0. And then we have the reverse. We have 7x to the 8th over 9x to the third, let's say. This one is going to approach one of two things, either positive infinity or negative infinity, depending on what limit we're dealing with. And what's left. So 7x to the 8th over 9x to the third. This is going to be an odd, so if I put in a negative infinity, my answer is going to be negative infinity. If I put in a positive infinity, it's going to be a positive infinity. What if I changed this to 5? X to the 5th divided by x to the third is x squared. If I put in a negative infinity, what's negative times a negative? Positive. So these are the ones here that you have to watch your sign of infinity. And that's our worksheet. Once you figure out the little shortcuts and kind of working at it, you guys will move pretty quickly through this one. Now, good luck.